Hi, it's Moser with a tutorial on compounds with polyatomic ions, naming and writing them. So after this video, you should be able to name any ionic compound containing a polyatomic ion when you're given the formula, and conversely, you should be able to write the formula for any ionic compound containing a polyatomic ion when you're given the name. You should already know what anions and cations are, the common ions made by the main group elements, how to write compound names and formulas for binary ionics, and it would be really helpful if you knew what polyatomic ions were, wouldn't it? Before you get started, please make sure that you have your periodic table and this handy-dandy reference sheet to the common polyatomic ions. This is the same reference sheet you used for the stock nomenclature system. So, we've got these polyatomic ions here, organized and divided. Well, what are polyatomic ions? Do you remember these? You did these when you did Lewis structures. You did ammonium, and you've done sulfate. You've done the nitrate ion. Mind you, I didn't draw the whole resonance for the nitrate ion, but we know what we're talking about. Those things. In polyatomic ions, remember that the atoms inside the polyatomic ion are sharing electrons. They're bonded covalently, while the whole entire cluster as a group has either lost or gained electrons. So in the case of the ammonia ion, it's lost an electron and it has a 1+ charge. In the case of the nitrate ion, it's gained an electron and has a 1- charge. The sulfate ion, SO4 2-, has gained 2 electrons and has a 2- charge. Well, here's the thing about polyatomic ions. They form ionic compounds just like monoatomic ions. Really, isn't that remarkable? So just as a recap and remember, what we already mentioned, they're atoms that are bonded together covalently and have lost or gained electrons. Now, there are some cations, but most of the polyatomic ions that we're going to deal with fall under the heading of oxyanions. So, because remember, chemists are so creative in naming things, these are anions, or negative polyatomic ions, that have oxygen in them. Well, that's pretty simple. Here's where it gets a little weird, and here's where I want you to take a very close look at your reference sheet. The endings really matter. So for any oxyanion, the most common ion that exists gets an ATE ending. The ion that has one less oxygen gets an ITE ending. See, here's the weird thing about the oxyanions. We will have multiple oxyanions comprised of nitrogen and oxygen, or chlorine and oxygen, or sulfur and oxygen. So we have to have these naming conventions to distinguish them. When there are more than 2 ions that are formed, we get into the hypos and the per-ates. The hypoites and the per-ates. We don't do a whole lot with those, but you should be aware of them. So paying attention to ending is really, really important. You might remember that when we talked about binary compounds with monoatomic anions, I pointed out that you should really pay attention to that IDE ending, because that tells you that it's a monoatomic ion, where in the case of polyatomics, we have the ATE and ITE endings. Let's just see what this looks like in a real-life example. So, say we come across sodium nitride, sodium nitrate, and sodium nitrite. Oops, there we go. Well, sodium nitride, IDE, is a sodium ion combined with a nitrogen atom that has gained 3 electrons to form a 3+. So we know the formula would be Na3N. Well, what about sodium nitrate? We would have to go to our reference sheet to discover that nitrate, right there, is NO3 1-. So sodium nitrate is NaNO3. Different compound, different characteristics, definitely not the same as sodium nitride. Now, sodium nitrite, NO2 1-. Remember, 1 less oxygen than the most common gets the ITE ending. So sodium nitrite is Na NO2. Again, different compound than either of the other two, and it's going to behave a little bit differently. Let's clear up one possible misconception before it starts. Do you have your reference sheet ready? Excellent. So let's look at those ATE and ITE endings in nitrogen. Well, we just did that. You just found those. And you know that NO3, 1 is the nitrate ion, while NO2, 1 is the nitrite ion. What about the polyatomic ions formed with sulfur? Because these are another one where we have multiples. You might be tempted to think that SO3 was the 8 ending, but it's not. Look closely at your reference sheet. Sulfate, in fact, has 4 oxygens, while sulfite has 3. It seems weird, but this is just to make sure that you're clear on the fact that those ATEs and ITEs and IDEs don't relate to the number of oxygens. The ATE and ITE in polyatomic ions relates to the most common and the one with one less oxygen than the most common. I know, it's strange, but you will get used to it when you've done it enough, I promise. So let's practice some formula writing. Let's say you've been given a formula for sodium sulfate. Well, you have to use your reference table. You obviously know the sodium ion. You know that that's Na1+. And if you look at your reference sheet, you'll find that sulfate ions are SO4, 2-. From here on out, it's just like writing the formula for a binary ionic, where we know that our subscripts are going to represent the ratio of ions. And when we look at this, it's pretty easy to tell that 2 sodium ions will balance out 1 sulfate ion. So we'll have Na2SO4 1. And we know we never write the 1 as a subscript, so our final formula would be Na2SO4. Easy peasy. Let's do some more. Calcium nitrate. So looking at the periodic table, you're well aware that calcium forms a 2+ ion, and looking at your reference sheet, you can find the nitrate ion, which of course we've already done a few times today, is NO3, 1-. So now it's just a matter of finding our ratio, and we know immediately that 1 calcium ion will be balanced by 2 nitrate ions. So we're going to write in our subscripts. There's just one problem. Things could get pretty confusing here because you have this 3 that's part of the polyatomic ion, and yet you have a 2 outside the nitrate. We use parentheses to distinguish that we mean that it's 1 calcium ion to 2 nitrate ions, and we have to use those parentheses anytime we have a compound that shows more than one of the polyatomic ions. In a case like this, you're more than welcome to do that, but you don't have to. People might laugh at you when you go on in chemistry, but that's okay. What about ammonium chloride? Well, chloride, we know, that's the chlorine ion. Ammonium, I've never heard of this before. What the heck is ammonium? Check your reference sheet. Look in the 1s column, +1 to be exact. Oh my gosh, could it be? It is. It's one of the few polyatomic cations that we work with. The ammonium ion, and you've done a Lewis structure for this undoubtedly, is NH4 1+. Well, since we can clearly see this is a 1-to-1 ratio, we're not going to have to write any subscripts, and our final formula for this will be NH4Cl. Again, if you feel like you need to set the polyatomic ion off in parentheses, you're welcome to do that, but it's really not necessary. Let's do one last formula writing before we go to naming, which is by far the easier part. So you know from looking at your periodic table that potassium, being in group 1, loses 1 electron to look like a noble gas, forming a potassium 1+ ion. And you've no doubt found on your reference sheet, you'll get better at using it, that the phosphate ion is PO4 3-. So let's find our ratio. And we know that 3 potassium ions would balance 1 phosphate ion. So our formula is K3PO4. Again, if you really feel the need to separate your polyatomic ion with parentheses, you can. It's probably a habit that you'll let go of as you get more fluent in this, but it's fine if you feel like you need to start that way. Now let's flip this on its head and go from formula names to compound names. Or compound formulas to compound names. NaNO3. Well, here's where you have to become pretty good at recognizing things, and I'll tell you in a little bit about the most common mistake people make. So first off, remember that the vast majority of the compounds that you'll work with at this level of chemistry, I'm assuming you're in a high school chemistry 1 class, are going to be oxyanions. So looking at the front, this is generally an element all by itself, and you should probably recognize it. You know that this one is sodium, and you know that whatever comes first should be the cation, and you know that sodium forms a cation. So this is just the name of the cation, sodium. Well, here's the trickier part, recognizing that this is a polyatomic ion. And again, as you become more familiar, as you get more practice with these, it'll become very natural for you to realize that, oh yeah, that's nitrate. Anytime you see more than 2 elements in a compound at this level of chemistry, you should be thinking that somewhere in there, there's a polyatomic ion. Guess what this is called? Sodium nitrate. Wow, that was easy. Okay, again, this is going to take a little bit of recognition on your part. You realize that that is, of course, calcium. And when you look at the second half of this formula, you're going to see OH. Now, again, this is more than 1 element, and it's set off in parentheses. So you should recognize that that's going to be a polyatomic ion. Did you find it yet on your reference sheet? Did you find that it's, in fact, the hydroxide ion? We just write the names of the ions, just like we did for binary ionics. Really pretty easy. Okay, here's another one. So I'm looking at this and I realize that that is, of course, the magnesium ion. Magnesium. And when I look at my reference sheet, knowing that, of course, this has got to be a polyatomic, I find that, what is this? The phosphate ion. So what I have here is magnesium phosphate. Okay, well that's a quick run through. So let me give you the big things that you can screw up. Here's the first on your hit parade of mistakes. What is that? CaOH2. Calcium hydroxide. What's wrong with it? Have you figured it out yet? When you're missing the parentheses around the hydroxide ion, what you're in fact saying is that you have 1 calcium, 1 oxygen, and 2 hydrogens. That's not the case. What you have is 1 calcium and 2 hydroxide ions. That makes a big difference. So error avoidance number 1, don't forget your parentheses when you need them. They do mean something. Error number 2 to avoid. The second mistake people make, and again, once you're really fluent with these, you won't make this mistake, is looking at this and going, well, let's see, that's sodium, and that's phosphorus, and that's oxygen. Okay, yeah, it's sodium phosphorus oxide. No! Remember to look for your polyatomic ions. Anytime you've got an anion with a cation partnered with 2 other things, you should be looking at that reference sheet. And until you've pretty well memorized a lot of them, you should be looking at it a lot. So check your reference sheet. That's what will help you avoid common mistake number 2. Other than that, it's practice, practice, practice. I've linked a practice sheet and key. There's also a game for the iPad that allows you to play Mahjong with the names of polyatomic ions. It's not bad when you're starting out as a way to learn. Okay, happy formula writing.